This is U5, evaluating recursive formulas for sequences, 9YD. I'm going to talk about how to work this out. So it gives you the first term in the sequence, and then it gives you the recursive sequence. Now we know this is an arithmetic sequence because we're taking the previous term and adding 8 to it. So that means our D is equal to 8 and our first term is 12. Now, when we're looking at a sequence like this that just has 2 terms in that sequence, I'm going to go ahead and just work out the next 2 terms. So I'm going to say 12 and I'm going to do plus 8, which gives me 20. And then I'm going to 20 plus 8 is going to give me 28. Okay, so that one's real straightforward and simple. Same with this sequence as well. I'm just going to do 8 plus 9, which gives me 17. And then 17 plus 9, which gives me 26. Now, I'm going to go to the next level. You actually have multiple levels on this one. We know that this is a recursive sequence. Now, honestly, you could on this go ahead and just find the first, because we're looking at the fourth term. So I can do 2. You know that their multiplier, your rate, is 4 because that's being multiplied by your previous term, a n minus 1. So 2 times 4 would give me 8. 8 times 4 would give me 32. And then 32 times 4 would give me 128. So this fourth term would be 128. Now, you can also write this as an explicit form instead. So in other words, I know my rate, I know my first term. So I can write the explicit formula to be my first term 2 times our rate 4 to the n minus 1. Now, why would I want to do that? Because if I go over here to Desmos and I go to, and I put in my equation, so I'm going to put A, now I'm going to put parentheses instead of the subscript. We said our first term was 2, and then we said our rate was 4. And then I'm going to do the exponent of n minus 1. Make sure you put parentheses, n minus 1. Now, I'm going to convert this to a table. This is going to give me all of the numbers in our sequence. Now, I'm going to go ahead and take out the zeros and the negatives because our sequence starts with 1. So we know that our sequence is going to be 2, 8, 32, and 128. I can continue going now that I know the terms in my sequence. And let's say I asked for the 99th term. So now that I know that I can write it as the explicit format, I can say A of 99, and that will give me my 99th term in this sequence. So that's all you got to do with that one. Let's see, jump a level here. This one's kind of tricky. This is probably one of the more challenging ones because this is it has a double. So that a n minus 1 means previous term. The a n minus 2 means previous 2 terms. Okay, so our first term is 0. Our second term is 1. That means this third term, we're going to do 1 plus 0, which is going to give me 1. So our third term is going to be 1. Now I'm going to take the fourth term, go to the previous term, which is 1, and then previous 2 terms, which is also 1. So now I'm going to add 1 plus 1, which means that's going to be 2. Now my third term is going to be the previous term, which is 2, plus the previous term from that, which is 1. So that gives me here as 3. Now you won't have any questions like this on the test, so don't worry about that question. Just get that set up and do it for the program, and then you'll be fine. All right. This one would be the minus previous terms. So this third term is going to be 3 minus 2. 3 minus 2 is 1, so that's going to give me 4. 4 minus 2 is 2, so that's going to give me 5. 5 minus 2 is 3, so our third term in the sequence is 4. That's going to be 6 minus 2. 6 minus 2 is 4, so that's our fourth term in the sequence, which is 5. That's all we're doing in this. That's 4, 5, 4, 5, 4, 5, 4, 5. Okay. All right, and this is done a similar way. I'm going to go ahead and jump up a level. Again, on these, just put this in Desmos and you'll be able to calculate it. Same with this one, just go ahead and put it in Desmos, or you can calculate it by hand and find those terms or write it as an explicit format. All right, that's all you got to do on those. See you next time.